Welcome to Study Loop.
In this problem, we have to go through a few steps to try to find an equilibrium concentration. We are given a reaction, and we are provided with its equilibrium constant Kc. We want to do an ice table here, but we have to do a little bit of work before we can get to our initial conditions. We are told that we have a 0.905 molar solution of sodium iO4. The sodium will always go off on its own and be an Na plus ion, so we don't have to worry about that. So this is in fact the same as having an iO4 minus solution that is 0.905 molar in concentration. We want to calculate our initial concentration, and we're told how much dilution happens. So we're going to use the equation M1V1 equals M2V2. Solving this for M2 equals M1V1 over V2, so that equals 0.905 molar times 25 mils over 500 mils. That gets us a concentration of 0.0453 molar. So that is going to be our starting point for our ice table, 0.0453. And for this problem, we are in an aqueous system, so there is a big excess of water, and we're just not going to worry about it. Now we're going to lose some of that concentration and gain it as H4IO6 minus. And get these expressions for our equilibrium concentrations. Next, we are going to assume x is small, and we will check that later. Kc equals 3.5 times 10 to the minus 2. And that equals products over reactants. So here x for H4IO6 minus over 0.0453 minus x, which comes from our other equilibrium concentration. But we're assuming that x is small, so we're going to get rid of the minus x. If you do this, you find that x equals 0.0016 molar. If you compare that number to 0.0453, you can see that it's a little smaller, but they are somewhat close to each other. So we're going to check this assumption that x is small by doing a little bit more math. We're once again going to start with the equilibrium constant of 3.5 times 10 to the minus 2. Once again solving for x, but this time we're going to plug in our old value of x to the denominator as an estimation of how much x would be lost from this system. And now if you do this math, so do the subtraction on bottom first, then multiply that over times 3.5 times 10 to the minus 2, you will find that x equals 0.0015 molar, so it has barely changed. If you wanted to verify this, you could do this process one more time, but we are at equilibrium here, so that is going to equal the equilibrium concentration of H4IO6 minus.